inheritance has to do with related classes. We learned about how to make classes previously, right? We made a class for Boggle and for other places in our work. And, classes being new types of objects, right? Well, sometimes you have multiple different classes of objects that are similar to each other, that are related to each other, and you want to express that in your code somehow, and inheritance is a way of doing that. So you can create what we call hierarchies of classes, where some of them are considered to be subclasses, subcategories of other ones. So for example, there's a lot of real-world analogies that work here. You can say, hey, in the world there are animals, and some animals are mammals, and some mammals are dogs, and some are horses, and some horses are Clydesdales, and some dogs are Labrador retrievers. So these are like subcategories within more general categories, right? And we have this understanding that every subgroup is a portion of the bigger group, and it has a lot in common. So like all the things that dogs have or that dogs can do, a Labrador can do. All the things that mammals can do, a dog can do. And so it's a more refined, more specific subcategory that maybe has a superset of the abilities of the parent, of the general category. Anyway, these are called hierarchies. So inheritance is when we write a class that's based on another class. You form a new class whose behavior is based on the behavior of some existing class. And you get some nice benefits from doing this. One is you get code sharing. If you have two classes that are similar, you don't have to write the code for both, for all the features twice. And the other benefit that you get is that there are some places now that you can use them together in code in certain ways that you could not have before. So there's some terminology here. The parent class that you're starting from is usually called the base class or the superclass. And then the other one that sort of is the more specific subcategory of that is called the subclass, sometimes called the child class or the derived class. And the way that you want to think of it is that the subclass gets its own copy of everything that was in the superclass for free. And you can add more or change existing behavior on top of that if you want to. So as one example, you guys are working on the Trailblazer program. And if you actually look at the source code for the provided files, then in there are these different types of worlds. There's a superclass called world. And then there are three different subclasses of world. There's map world and maze world and terrain world. And there is a lot of common code that all three of those classes would share. And so I put the common code in the world file, and the specific code I put in each of the three subclass files. So, I mean, if you're just curious, you could look at that code later and see what that looks like. It's one of many examples. There's also these graphical objects in the C++ library. We didn't use them very much in this class. We used like G window, and we drew some lines. We used a G buffer image for filling in colors in recursion assignment 3. But we didn't use this very much. But there's also these graphical libraries that all are subclasses of a superclass called GObject that has some common drawing code inside of it. Here are some of the members it has. I'm not going to spend time on that. But I mean, the point is that anything that every kind of shape can do, you put in a superclass, like having a color and a position and being visible or invisible. That's all stuff that basically every shape would want. You put that up there, and anything that's specific to a certain kind of class, you put down in the subclass file. Okay? So one example I use this sometimes in 106A as well. I use this inheritance hierarchy example of like maybe you're going to write classes to model employees at a company. And there's different categories of employees that work at this company, and they have different policies for each category. Maybe this is a law firm, and so there are some secretaries who work there, and there are janitors who work there, and there are lawyers who work there, and there's advertising people. There's all these different kind of employees, and maybe there's a lot of policies and rules and data that are general that every employee follows, and then there's some specific rules that certain kinds of employees follow. Like maybe you use a certain number of vacation days or dollars per year salary, but then there are certain categories that differ a little bit from those things. Also, maybe in addition to all these general rules, there are some specific rules that each kind of employee has a certain type of special ability that only they can do. Only lawyers know how to sue people. I don't know if that's true or not, but know how to actually conduct a lawsuit. But if there's programmers at the company, they know how to write the code and this kind of stuff. So how do you model this with classes? Well, you could write an employee class. This class is kind of silly. I mean, this is meant to be kind of a dumbed down example so I could talk about the mechanics, right? But just work with me. You make a class called employee, And you remember when we write classes, we have an H file with the declaration of everything and the CPP file where we write in the bodies, right? You guys remember that. So here are all the methods. You can make an employee object, and you pass in the string of what their name is and the int for how many years they've worked at the company. And then there's all these methods you can call to ask them things about themselves. And then the code to implement those, most of the methods are pretty straightforward. The salary is you make $40,000 plus you get 500 more bucks for every year that you have worked at the company. Sounds like a pretty crap wage for a lawyer to make in the Bay Area, but I mean, that's like a below poverty line, right? I don't know. I just made up the numbers, but whatever. You get 2 weeks of vacation, so that's 10 days, and these are the methods that an employee class might have. Okay, well then you say, well, but I have these different subcategories of employees. I have lawyers, and I have secretaries, and I have programmers, and this kind of stuff. So then you say, okay, well, I'm going to write a class for lawyers. Okay, well, a lawyer has a little bit more stuff. They're pretty similar to a regular employee, but maybe in addition to knowing their name and how long they've worked at the firm, they also keep track of what law school they went to as a string. And maybe they make, twice as much money as the normal employee. So 80 grand plus $1,000 a year instead of 40 grand plus $500 a year. And they know how to sue people. Okay, well, if I were going to write out that lawyer class, what you would find is that the lawyer class contents would be extremely similar to the employee class. If you didn't know anything about like inheritance from today, you would just write out a lawyer class, and very many of the methods and things would look the same as what they look like in the employee class, right? So now you'll have two classes that are kind of redundant with each other, and they seem like they're related to each other. So the way you fix this is you say that lawyer is like a more specific kind of employee. It is a subclass. It extends the employee class. And then we only have to write the parts that are new or changed or different from regular employees. So here's kind of the way you do that. There's also some stuff here about programmer class, but we'll get to that. So here's the syntax. In the heading of the class, in the .h file, when you are writing the class, you say, hey, this thing extends employee by writing class lawyer : public employee. Why do you say it that way? In Java, you say class lawyer extends employee, which I think is a more natural syntax, but C++ is older than Java, so Java had the benefit of a decade to think about this. And so by writing class lawyer : public something, whatever comes after the word public is like you're saying that's your parent class. And now, just by writing that, only writing that, the lawyer class now has a copy of all the stuff in the employee class. All of this is now in lawyer as well, without me having to write it. So that's kind of cool, right? That's pretty nice. So really, what we would need to do from that point is we would need to add anything that lawyers can do that isn't here. And we would also need to think about modifying anything that we need to change. So, okay, this is a start. And let me go to, well, at some point I'm going to jump to Qt Creator, but I think not yet, actually. Now, the next thing I want to do is, I mentioned that some of the existing rules for employees are changed for lawyers, right? Remember how I said they make twice as much money? Okay. Well, if I say class lawyer public employee, let me jump. Maybe now is the time for me to jump to Qt Creator. Where is it? I think it's this project. I've got employee.cpp and I've got lawyer.cpp. Let me just nuke this for a second. There. So if that's what I have, where lawyer just extends employee, I say, well, gosh, the employee has a get salary method that returns, 40K plus 500 per year. But I want mine to be 80K plus $1,000 per year, twice as much. So how do I do that? Well, the thing about inheritance is you cannot selectively inherit. Like you might say, well, I want the lawyer class to receive a copy of all the stuff from the employee class, but I don't want the get salary method. I want to write my own version of get salary method. That's kind of what I'm trying to say here. So there's not a way to say, I want to inherit everything from employee except for the get salary method. There isn't a way of saying that. But what you can do is if you just rewrite get salary a second time in the lawyer class, the new one in the lawyer class will replace the old one from the employee class. So that's what you do. That's called overriding a method. But like I said, you can't extend a class without getting all of its behavior inherited into you. But if you don't like some of that behavior, then just rewrite it to do what you want, okay? But there is one thing that you have to do. If you want to override a method, basically all you have to do is just rewrite the method using the same syntax as usual. Just write getSalary method in the lawyer class. That's it. But there's one thing you have to do. In order to make a method overrideable, you have to use this special keyword when you write the method, which is called the virtual keyword. So the virtual keyword is a word that you can put in your code at the start of when you're declaring it as a method. And without trying to get too fancy at the moment, basically what that word means is I allow this method to be replaced in my subclasses if they want to. It's like you're telling the compiler, it's okay if my subclass wants to write a new version of this. That's okay with me. So honestly, a good rule of thumb is when you're writing classes, making everything virtual is probably fine in general. Because you never know if somebody wants to extend your class, maybe they want to write a new version of your method, you should just let them, unless you have a good reason not to. So most people make lots of their methods virtual when they write classes. If you look at my code for like world maps in Trailblazer, you'll find that most all of the methods are virtual because I want to do overriding. So anyway, you would want to go back to employee.cpp and employee.h, and you would want to declare all these methods as being virtual methods. So now the subclasses can override them. And then if I want to override getSalary in the lawyer, I would just say, well, OK, double, I guess this is in the public part of the lawyer class, double getSalary, and then I think it's const. You have to have the same header, or I guess it's still virtual. You have to have the same header that the superclass had. So, oh, it's just called salary, not getSalary. Sorry. So just exactly the same header here, and then I would go to lawyer.cpp, and I would write the body for this. And now my new version replaces the old one. Okay? If you don't use the word virtual, and then you write a new version of the method in the lawyer class, it gets a little weird because now there are two versions, and they're both there. It gets a little bit complicated at that point. But maybe for the moment, I'll just say, do this. Don't not do this. So far, so good. Any questions? Yeah.
One, do you have to precede the function kind of regex in your subclass? Does that also have to be preceded by virtual?
In both the superclass and the subclass, you should write virtual. Yeah, both. Mm-hmm.
And is there any reason not to do this?
Is there any reason not to make something virtual?
Yes.
I almost hate to tell you because some of you will latch onto this, but it's a little bit more efficient not to make it virtual. And so all you nerds go, oh, efficiency, and you don't want to write virtual anymore. But I'm talking about like one instruction in the CPU that you will never see. You know what I mean? It's just the teeniest, tiniest, and the compiler can optimize it. And it's a little bit slower if you don't make it virtual. But like I said, I almost didn't even want to tell you that because it doesn't matter, and you shouldn't even think about that when you write these things. Like people who write device drivers deep in the bowels of an operating system, they might do a timing test and make something non-virtual because it saved them 10 cycles over an hour. That won't be you, probably. You'll do something else. You won't write that code. You don't need to worry about that. So anyway, yeah, but I do agree with the general gist of why you asked that question, which is why don't we just always make the methods virtual? But the answer is, yeah, make them all virtual. Do it. That's what you should do. I like that. I think that's what you should do. OK, so that's overriding a method. So the lawyer class, you could write these virtual re-implementations of methods as needed. OK, so let's learn a few other things. One thing is that if I went to the lawyer class, I think the problem is I didn't clear this out ahead of time. So I think the solution is already in here. But I told you that I want the salary to be twice as much, right? So maybe I'm going to jump to the CPP file in a second. But maybe when we wrote the actual body of this thing, the actual salary method, you'd say something like return 80,000 plus 1,000 times years. You something like that. That's what you would write in the CPP file. But really what I wanted to say was twice as much money as everybody else, right? And this expression that I have highlighted is twice as much money as everybody else. But what you find later is like, what if you give the whole company a raise? You make the base salary 50K instead of 40K. Oops, then this one still uses 80K, and 80K is no longer twice as much as 50K. So now those two could get out of sync with each other. And so you really wish you could just say 2 times the old salary or something like that, right? And so there is a way of saying that. And the way that you end up saying it is in the CPP file for lawyer, you write, return the employee class's salary times 2. And you write with this funny syntax. You write class name, colon, colon, method name. And that will call the superclass's version of the salary method and return whatever it returns. And then I will double that for me. That's better code because if I change one, the other one will update automatically. So that's kind of the, the way we're going to do this here. Okay? There's a couple of things going on here that we also need to think about. Like employees, the constructor for employees takes a name and a number of years, and it stores them as fields. I just called them M underscore, like members, like my name, my years. So fine, the employee constructor takes in parameters and uses them to set these fields right here, right? Well, then the lawyer constructor takes in the same parameters plus a law school, a name, a law school, and a number of years. So you might say, well, okay, M name equals name, M law school equals law school, M years equals years. That's kind of the analogous thing to do, set all 3 of the variables. Because keep in mind, if you look at the lawyer class, the only variable that he declares is probably private string M law school. That's the only new piece of state, the only new variable that the lawyer needs to add on top of what he already inherits from employee. So I'll declare it here, and I'll set it here. But I'm also getting my name and my years, and I need to set those as well. One thing that's kind of goofy that you'll discover is that these lines of code right here actually don't compile. And it's pretty silly. It's basically because the employee thinks of those as being private, and they're so private that they're even forbidden for the subclass to see, which seems kind of counterintuitive. Like if the lawyer is an employee, how come he can't look at his own data? But the zen of OO programming is, well, they're not really his data. They're his ancestors' data. It's sacred or something. I don't know what. There's probably some kind of Game of Thrones joke I should be making here or something. But something about Jon Snow. But anyway, you can't directly access the name and the years like this. So what you can do instead is, like I said, the reason you can't do it is because they are private in the employee type. And the lawyer, being a subcategory, can't see them. Okay, so what you could do instead is if you had a method like set name, you could call that if it was a public method. That would be legal. So that's one thing. You sometimes do it that way. You say set years, The other thing that you sometimes do is you want just in the same way that the salary method called the superclass's salary method, maybe you want the lawyer constructor to call the employee constructor, right? So like, how would you do that? I mean, here you'd want to say like employee colon, colon, employee or something. You want to call the constructor and pass name and years or something like that. And that's the right idea, but or just like that or something. But it doesn't actually work. That's not quite the right syntax for that. So if you want one constructor, like a subclass constructor, to call a superclass constructor, you have to do it using this goofy syntax where you say, this constructor is based on, colon, a call to the employee constructor that takes the name and the years first. Do you see that? That's pretty kooky looking syntax if you ask me. But the meaning of that is like this constructor, the first thing it should do is call the employee constructor and pass up this name and pass up these years. And then in addition, the next thing it should do is set my law school variable. So the combination of all that sets the 3 variables. So that's a little weird, but does that make sense? Like, do you guys have a question? Do you understand what that's doing there? Like, I mean, I know constructors in general are a little bit confusing, but. So that's here, calling a superclass's constructor. Technically, that syntax is called an initialization list, whatever. Okay, well, so then I mentioned this already, calling the lawyer salary method can call the employee salary method. That's already code that we've seen before. Okay, so here's lawyer. I guess we kind of did this, lawyer, yeah. And like I said, the lawyer adds some new behavior, being able to sue people, right? So I add that by just writing more methods in the lawyer class, whatever. I mean, it's a silly class, right? Just prints a dumb message. But I mean, the whole point is the lawyer is now able to borrow all the code from employee. It can add new code that wasn't there before, like suing people. And now that's a new thing that only lawyers can do, general employees cannot do. And I hope it's understandable. I wouldn't want to just take the suing people code and put it in the employee class, right? Do you understand? Like, that would still work. The lawyer class would still be able to sue people if I did that. But do you understand like why that would be a bad design? Yes, sir?
Because janitors can't sue people, but they're also employees.
Right, because then you'd have like a janitor who's an employee, and then they try to sue somebody or handle a prosecution of, I mean, I guess it's not really suing people. It's more of, yeah, exactly. I don't want the other type of employee to do that. I don't want the janitor to show up at the case like, oh, I got it, I'll defend you, whatever, right? So that's right. So it restricts this behavior to only lawyers, but all the general behavior is still up there in the employee type. So I hope you see, like, inheritance is good. You copy all that code. You can add new stuff that you need. You can also modify / replace things that you want to change from what you inherited, right? That's where we are so far. Okay. C++ is lots of fun because it allows something called multiple inheritance. Multiple inheritance is when you extend more than one class. This is a feature that doesn't exist in a lot of languages. Java, Python, a lot of other languages that have classes, they don't allow multiple inheritance. They only allow you to extend one parent. C++ rolls with it. They let you extend as many classes as you want, and so you inherit the code from all of them. For a long time when I was teaching, I used to say this is like Pokemon, but then somebody told me that's totally wrong. I thought that when the Pokemon kill each other, they got their powers or something, but apparently that's not what happens. You do know that I'm really old, right? I'm like almost 40. So I guess what happens is when you kill a Pokemon, he turns into a ball, and then you have him, and you can have him kill people for you or something. But the existing Pokemon doesn't get the powers of the new Pokemon or something. So basically, I don't have any good analogy anymore. But I still repeat the bad analogy, but then I admit that it's a bad analogy. But so you can extend more than one class. And like I said, you'll inherit all the code from both of them, or from all n of them if you extend n parent classes. The reasons that most newer languages don't allow this feature is because it can be really weird and confusing what it does. Like, what if both of the parents have a method with the same name, or a variable inside with the same name? How does it know which one that the subclass should get? Technically, it gets both of them, and then it gets really confused when you try to talk to one. Sometimes it goes to the other one. Many bugs have come about from this crap. And so basically, people have decided this is hard to do right, and so most object-oriented languages just don't allow it anymore. But hey, we're in C++ land, so you can do it if you want to. That's fun. I'm not going to do a demo of it or anything, though. You can also do something called private inheritance. This is my Jon Snow example right here, right? But private inheritance is when you want to copy over the code from the superclass, but you don't want anybody to know. You don't want anybody to know who your parents are, basically. So it's hard for me to give you good examples of when that's useful. I think in terms of your understanding that I would test you on or something, I wouldn't show you this. But I just want to mention, like, when we do inheritance, we normally say :public, which means like any other class could tell that I extend this parent, and they know that. That's OK. But private inheritance means sort of like, I want their code, but I don't want anybody to know where I came from or where I got this code from. It's more of a subtle use case. We're not going to really go into it.